Hello there. Yeah, and renewables. I do a lot of work on renewables. In fact, it's probably the majority of my work. So yeah, marine ecology surveys in the offshore renewables. Basically, this was touched on yesterday, what lies beneath, but also what lies on the surface, what lies on the coast, anything basically where a development has interactions with the marine environment. We're involved in surveys for licensing, etc., amongst other things. Some may have noticed that I replaced the originally programmed talk, Understanding Ecological Consequences of Offshore Wind, with this talk, because I think that this talk is actually, what I'm doing is I'm providing solutions. I'm not trying to cause problems. I'm highlighting issues, but I'm providing solutions to those issues, which have to be considered in any development. However, I will use the term environmental a lot, relating to the service provided as a ready substitute for the science of marine ecology. I will also hopefully bring a bit of life to the convention. Not necessarily excitement, but squishy and not so squishy life. Don't expect a blue planet though. There will be some pretty pictures of big toys as well there, or small toys. So, part of decarbonising is and will be energy transition, and Fugro have been involved in the beginning in acquiring geodata to facilitate licensing, construction, maintenance of energy transition projects, including renewables, but also carbon capture and hydrogen production, preferably green. From Fugro's beginnings in the marine site characterization for the offshore renewables industry over 25 years ago with this wind farm, and acquiring geodata for offshore wind concurrently at the beginning with non-integrated environmental assessments in the early 2000s, Fugro progressed to supporting 50% of wind farm developments globally with a fully integrated service. Our current geodata assets include these, the majority from which have some environmental data acquired or informed, and I will cover as much as possible in the confines of this presentation. Fugro, for this audience, lie nicely between the, as a client of vessel development and vessel supply, and also large systems, launch and recovery systems, and then we are, on the other side, we are the supplier of services for any developers and asset integrity in the marine environment. Our full range of services include metocean, environmental, geophysical, geotechnical, geoconsultancy, and digital delivery. But though I'll be speaking primarily on environmental, I will show marine ecological services to be just part of the integrated package that Fugro offer, all providing geodata, including geospatial, positioning, acid condition, and change detection. Marine services and marine environmental services do not work in isolation. That's very important because a lot of projects we have, sometimes we're just the only package involved, and we will be acquiring geophysical data from elsewhere, but they work very much in tandem, and it really is a good thing to have this fully integrated service. Indeed, geodata, including environmental data, is essential for site characterization, for licensing, construction, continued operations, including environmental monitoring and maintenance solutions. Two consistently integrated services, as I've said, are environmental and geophysical. From intertidal to deep sea, these dynamically work in tandem or consecutively, both informing the other in data analysis and interpretation. We work very closely with our geophysical team in Fugro. Not just from nearshore or offshore vessels, but through satellite data, which hydrographic and habitat modeling as well, via additional area and drone data, and additionally offshore with automated underwater vehicles and remotely uncrewed surface vessels. Fugro offer an ever-expanding range of remote services. This will be touched on this will be discussed a bit more, hopefully, in the following conversation with Ben. following presentation, but I'll just do an overview of what we currently do and should fill in some gaps from yesterday. Remote operations are inevitable and will become more and more prevalent, including marine ecological surveys. We have already acquired visual data remotely and analysing more quickly and dynamically onshore to suit client reporting requirements and schedule. We hope in the near future that to be acquiring water and sediment chemistry samples remotely with potential for real-time chemistry data acquisition. We undertake remote marine manual observations, or MMO, passive acoustic monitoring, or PAM, both for pure data acquisition of marine mammal sound and anthropogenic noise, and mitigation for geophysical surveys and constructions or installations. And that's needed more and more, especially anybody working in the North Sea on developments. They've slapped a big special area conservation right in the middle of the North Sea, and any geophysical survey now needs to have some kind of element of MMO and PAM for mitigation. Marine sound will become more and more important as well in licensing and construction as we further understand the importance of all marine animal sounds with ecosystems and effects of anthropogenic noise on those ecosystems. So developers, be warned, the more knowledge we get, the more we know about the environment, the more that has to be considered. Remote operations are focused around 4 key services. So remote survey, remote piloting, remote positioning, and remote inspection. Communications between offshore and onshore and offshore is via internet and telecom linked-based communications, and remote operations will reduce risk to personnel, reduce survey time and therefore costs, and increase sustainability towards our goals of zero net emissions. We do have great hopes for ecological surveys and our newly commissioned uncrewed surface vessel, adding to our continuing use of autonomous underwater vehicles. And this is the first of 2 vessels, this Blue Essence at the top, which I'll go into a bit more detail. It's a 12-meter vessel, and the next vessel long, which is just about to be launched, or may have just been launched, is 18 meters. So this shows us different views of our USV, Blue Essence. The top and aft view at the bottom and right-hand side of the slide illustrate the launch and recovery ramp at the center of the vessel. And the launch recovery ramp, combined with the ability to submerge the stern of the vessel, allows the ROV to swim in and out during launch and recovery. So that's how that goes. Next slide shows the payload, the components on Blue Essence. The payload distinguishes the following systems. For beyond line of sight operations and service positioning and navigation, we have a Starfix navigational suite and SatGuard installed. For situational awareness and safe navigation from remote operations, the vessel is equipped with radar and AIS, including vessel tracking, and CCTV and thermal cameras. For communications, the big dome on the back that you can see there is the VSAT for ship-to-shore connectivity. The Iridium system is the secondary SATCOM system. It can carry too much information, but it can direct where to go, what to do, and download and upload limited data. In addition, the vessel is equipped with dual UHF and Wi-Fi for on-site and vessel-to-vessel communication. There are 2 types of data acquisition: the gondola, that can host a variety of systems, for example, a multi-beam or sub-bottom profiler, or your hydrophone array for marine sound acquisition. The second option is the Blue Volta ROV, and that can carry a range of environmental sensors and equipment, and other types of sensors and equipment. So getting into the environmental services, why? Well, to inform legislation compliance and to do the right thing. And also public relations, including global reputational gains, to be seen to be doing the right thing. And we do find the public relations side of things more and more. I mean, a lot of places in the world now take on either US or EU stemming from EU legislation and incorporate it into it. Because rather than inventing it yourself, it's already there. Even beyond PR, most places in the world now will have some kind of legislation based on other systems in the world. Marine ecological projects can involve benthic or seafloor, as we've already said, and water column surveys, sensitive habitat assessments, MMO, PAM, fisheries, marine growth assessments which monitor asset integrity, non-native species risk assessments mitigating construction and transit risk, additional to species migration risks due to global warming. We did a scoping study for construction of a base station down in the Canaries because they had a big enough floating dock there to develop that. And that was to be installed in north of Scotland. And they were passing through 3 biogenic zones. And there was, especially in Scotland, there was a lot of consideration for non-native species potential introduction. So that is something we do as well in risk assessments, how fast it has to go, where it can stop, if it can stop even. So it reduces that risk. Also, I added this at the last moment, eDNA, environmental DNA is going to become, sorry, I just lost my place there. Yeah, environmental DNA. This will become more and more important in future surveys as, amongst other things, it offers replacement to more destructive sampling methods, such as trawling, which is still currently needed to inform some environmental impact assessments. eDNA provides a more comprehensive view of use of sampling location by marine fauna or animals, including potentially protected rare and endangered species. And that's a good thing, because the more you know, the more you can inform the EIA, and the more you can potentially scope out any problems against stakeholders and regulators. eDNA also provides information on how to monitor species such as bacteria and meiofauna. These aren't normally surveyed, but they do indicate change quicker in shorter time frames than other standard current survey and analysis. So, however, mechanical sampling is still required and still works, though remote operations are creeping in. Seabed sampling, for example, the box corer here, which is a 0.25 meter squared corer, usually used in deeper water because it's very reliable, and sometimes you can be doing a drop of 25 minutes, even 2 hours, and then bringing it back up, and you don't want an empty grub. But we do normally use in shallower waters, we use an array of grabs, Hammond grabs, mini Hammond grabs, day grabs, whatever suits the requirement or the sediment surface. And we have double versions of these as well, basically anything that is required. So these acquire sediment samples for biological, physical, and chemical analyses. We do use megacorers again, not for the renewables industry, or I should say not for the renewables industry yet. We adapt to new developments further and further offshore. For example, currently there's a proposed renewables in deeper waters, which including energy supply to an oil and gas installation, and onshore, true floating wind farms that we're involved in. And but also, next, last on the list, not so much for renewables again, but but I wanted to give a good scope of the marine ecological surveys, and includes water sampling, including see these Niskins and water profilers as well. That's the water profiler up here. The water profiler will take various things going down through it, a profile of the water, conductivity, temperature, pressure, dissolved oxygen, and turbidity, amongst other things, chlorophyll. There's various other sensors that can be fitted to that. The Niskins take water samples at specified depths, usually top, middle, bottom, unless you're in really shallow waters. And these are used for chemical analyses and also some biological samples as well. Also, we do have what's called a rosette, which is an array of the an array of the Niskin bottles in a circle, which can take multiple samples at multiple depths using the CTD to trigger them at the depths you require them. Habitat assessment. Visual and geophysical data, these are always required for new developments to assess presence of protected habitats, and if present, classify the habitats against legislation. In shallower waters, ecologically speaking, we're talking about 100 meters down to maybe 200 meters. That's my view of shallow waters. I know Deep Sea Port's view of deep water is a little different. But ecologically speaking, we're talking about probably 100 to 200 meters tops for shallow water, down to the continental shelf. But, you know, renewables are going further and further offshore. The licensing, and in other parts of the world, the continental shelf is quite close to the shore. So you don't know what you are going to potentially interact with. There is a range of legislation stemming originally from EU, which is now incorporated into UK law. There's also UK BAPs as well. All of these, we monitor and look for basically biogenic and geogenic reef, coming from animals, coming from geology-based sources. Habitats, seagrass, reefs, sea pens, burying megafauna, seagrass, corals, seeps. Also, these do occur in shallow waters. In deeper waters, we got cold water coral reefs, which I'll go on to later. Hydrothermal vents, just thought I'd chuck that in there. That's not going to be affected unless you're deep sea mining. There's a range of things, and they do already have legislation to protect them. So you do have to monitor them. Generally, habitats are surveyed and assessed, firstly through geophysical data acquisition. These inform potential survey locations and sampling with whatever method of visual data acquisition. So these can be ROV, drop-down video. So drop-down video is, and this is a drop-down video, these can also be put along a transect on the seafloor to take a transect of video and stills, and ROV as well, but also AUV. So we look at geophysical data such as multi-beam echo sound and bathymetry data, and side scan sonar, or how hard, how soft, it's a very layman term, of the seafloor is, and to inform on what habitats may be present, to actually look to direct the survey, and look at the habitats that are present. And these inform, you go back to the geophysical data once you have the environmental data, and delineate the habitats that any identified habitats. Similar method is used for sensitive habitats, those requiring survey through legislation. And what we do, same thing again, we acquire the geophysical data to direct the sampling of potential sensitive habitats. And we look at and then we look at the sensitive habitats. This is probably not known to most people in the audience. This is Sabellaria Reef, and in this case, it is a reef. Most of the cases, it is not a reef, but it is ubiquitous around the UK coast and the Irish coast and well, anywhere in the North Sea, basically. But it moves around a lot because it gets disturbed a lot, both naturally and non-naturally, and it tends to grow very quickly. One of these, this can probably grow in the space of a season, a marine season, 3 months. They are tiny animals. They're less than 5 mil, and they can grow very quickly in communities. And they create reefs which do attract communities and fishermen. But fishermen aren't covered by legislation, so fishermen can do anything they want with them. So we look at these, we classify them using reference systems, and then we go back and we map it on the geophysical data. So it is a circular thing. We also ground truth the geophysical data with environmental data, and that provides a seabed analysis for the geophysical, what's on the seafloor, and it ground truths their data. So we work in a circle. It's not just unique for geophysical or unique for environmental. Also, other biogenic reefs could be subtidal or intertidal mussel beds if they do become established. Similar methodology for geogenic reefs, especially here, cobble reefs, but potentially chalk reefs as well. So it's the same thing again. You identify from the geophysical data, identify areas for surveys, identify from the visual data, and then you classify and map the risk. This is another example, but from deeper water. So cold water corals are usually located in continental shelves at depths greater than 200 meters. As such, risk to renewables is low, but again, renewables is going further and further offshore, especially in areas where the continental shelf is relatively near the coast. Reefs may become impacted by anchoring and cable routing. This is acquired data, visually data, and again, we delineate, in this case, along a transit and classify the reef system along that transit. And that directs the developers where they can and can't go. It's another example, same thing again. Seeps are relatively rare, but form important sensitive habitats and biota, often dominated by chemoautotrophic microbes. Autogenic precipitates create structures from vent seep fluids ranging from metal-rich sulfate, sulfide, or silica deposits, and these are the hot vents at 200 to 400 degrees, unlikely to be impacted, as I've mentioned, except by deep-sea mining potentially. But they also include carbonates at hydrocarbon seeps and in ambient water temperature. The ambient seeps do occur in shallow waters of the North Sea and the Irish Sea, and we've also just been told, I'm involved in a project up in Sweden as well. This indicates where they found them, but I've got one where potentially they didn't know they existed, and that's a bit of a headache for the construction, but we have the data to inform them how to work around these problems. Cold seeps or methane-derived autogenic carbonates, MDACs, form a hard substrate which is often colonized by non-chemoautotrophic fauna. So they create a reef and they create fauna. Fauna is attracted to that reef, specific to MDACs. I do some work in the oil and gas industry as well. I like to tell people I work on renewables, but I do work in the oil and gas industry as well. And unfortunately, MDACs are a really good indicator of where oil is near the surface. Oil and gas is near the surface. So, in the UK, they're protected, so you have to kind of shift over to the side and do some horizontal drilling to get to where you want to get to. Precise geolocation through surveying, analyzing and classifying risk in the potential presence of sensitive habitats thus informs cable routing through geophysical environmental data if used together with ground truth modeling for optimizing route. Further detail for high-risk areas can be assessed with derivative geophysical data to microsite installations and routing. Here we've got processing of geophysical data to produce rugosity, showing roughness of the seafloor, and microelevation. This is all derived from BATI data. It just goes through, I don't know what they do, but it goes through it and it creates a microelevation map of what's on the seafloor, and that's really useful for identifying what is a reef and what is not a reef, and that's important. And what is a reef and what is not a reef is important to the regulators. So we can tell people where it exists, if it doesn't exist, and where it does not exist, and that thus opens up routing options within an export cable corridor, in this case, overlaying classification with video data you can see on these transects. This is an interesting case, actually, because this is what appears to be a massive reef right across the cable corridor for a renewables industry, and which is a problem to them. But we were able to show through the video data and through this microelevation data that it wasn't a reef. It looked like a reef, and we had to explain to the regulators why it wasn't a reef quite carefully. But it's quite an immense structure across the whole of the corridor, but it only appeared in, it only protruded from the sediment in certain areas. It protruded from the sediment, but was being constantly smothered because it was a highly hydrodynamic area. Sabellaria loved this, but it wasn't a reef. It was a nuanced thing. So this data informs nicely to the regulators and for the client where they can and can't go. In this case, we could tell them where they could put the route rather than some areas where they couldn't. Cheers, okay. So linking back to AUV surveys for habitat assessments, identify the area of interest with standard geophysical techniques, multi-beam, side-scan sonar, So look at that with the AUVs and SSS weights with high definition mosaics. These high definition mosaics, these image mosaics from the AUVs are further analysed as before to demarcate habitats as previous. The very high definition mosaics are excellent data for analysis and image resolution to continually evolving, allowing not only sensitive habitat assessments but identification of species where possible. This negates the usual requirement for marine ecologists like me to sample animals to identify and classify them, which has been most of my life's work. It also produces very nice images which tell a story, and it is such good resolution that you can potentially identify species on the seafloor. So pulling all these together, just be a minute. Just pulling all these together, what do we do with the data? The data is pulled together, and we are developing, we have developed a cloud-based system solution for it. So both to store data and continually to inform new projects and produce ground models to better inform current developments and potential for future developments. What do we do with these data long term? Most data acquired on vessels is delivered via data drops for onshore analysis. Some can be analysed remotely at high level in real time onshore in order to direct surveys, but we're looking towards complete remote operations in tandem with crewed and non-crewed operations. For environmental data, that may just simply be a geodata point with all survey data, analysis and relevant outputs, but with full integration into all acquired geodata from other sources to the Gaia Hub, which is the cloud service that we provide. Now, the Gaia Hub, what is that? It's a cloud-based geodata engagement platform that transforms the influx of varying volumes and complexity of geodata into meaningful insights for informed on-site time decision-making throughout the life cycle of assets. I barely understand that, so no difficult questions on that, please. Thanks very much.